everybody, in this video we're going to talk about how to multiply mixed numbers. So let's start off by using a number line model, and let's multiply 1 3/4 times 2 1/2. So if I have 1 3/4 times 2 1/2, that means I'm going to make 2 1/2 copies of the number 1 3/4. So I'm going to go ahead and split up my number line into fourths here so that I can have consistent measurements. So if I make one copy of 1 3/4, I'm going to go past the 1 mark, and then I'm going to go to the 3/4 mark. So this is making one copy of 1 3/4. And then if I make a second copy of 1 3/4, well, going 1 unit from 1 3/4 will take me to the 2 3/4 mark. And then I'll need to go 3 more fourths after that. So that's going to be this mark right here. And then the next thing I need to do is I need to make a half of a copy. So I'm going to do this one at a time. And I'm going to say, okay, well, half of 1 is a half. So that would get me to the 4 mark because that's a half of a unit. And then half of 3/4, well, my 3/4 mark is right here. And halfway between that is going to be right here. So this mark right here is going to be 2 1/2 copies of 1 3/4. So I need to look at this and say, okay, well, what is that mark? Because it's not on any of the fourth marks that I wrote in black. But if I split up all of my fourth marks in half like this, that shows me that this mark is going to be the 3/8 mark, or rather the 4 3/8 mark. And so when I multiply these fractions together, 1 3/4 times 2 1/2 equals 4 3/8. So when we look at this example, it might be pretty obvious where the 3/8 comes from, because 3 times 1 is 3, 4 times 2 is 8, and that equals 3/8. But it's a little bit puzzling where this 4 comes from, because 1 times 2 does not equal 4. And the reason why you can't just multiply the whole numbers and the fractions together is easier to see if we look at an area model. So if we look at an area model of 1 3/4 times 2 1/2, one side of my rectangle is going to be 1 3/4 of a unit long. So this is going to be the length of one side of my rectangle. And then the other side of my rectangle is going to be 2 units and a half of a unit. And so that's going to be the other side of my rectangle, and I can go ahead and fill this in right here. So if I want to find the area of this rectangle, I'm going to go ahead and extend these lines that I drew when I was defining the side lengths of the rectangle. So I'll extend this line here, this line here, this line here, as well as this line here. And when I look at this, I'm going to kind of look at it in 4 different sections. So the first section I'm going to look at is this part right here. So the area of this part is 1 times 2, which tells me that I have 2 square units within that space, which makes sense. The next space I'm going to look at is this part right here. So this part is 1 unit by a half a unit. So we're basically multiplying 1 times 1/2, which tells me that I have 1/2 of a unit in that space. Then this space right here is going to be 3/4 times 2, because I have 2 units long and 3/4 of a unit wide. And that's going to give me 6/4. And if you look at it, that makes sense because each one of these little rectangles is a fourth of a square unit. And altogether, I have 6/4. And then the last step is going to be this part right here. So this part right here is 3/4 times 1/2, which equals the 3/8. So when you look at this, notice that we're essentially doing 1 times 2 to get this part. Then we do 1 times a half to get this part. And we do 3/4 times 2 to get this part. And then 3/4 times 1/2 to get this part. and that gives me the area of the entire rectangle. And you might notice that this is very similar to the process that we do when we FOIL in algebra. The only difference is that we have whole numbers and fractions instead of variables and constants. But the idea is very, very similar. And then once you find the area of all of the little parts, then you just add it all together. And you say, okay, well, 6/4 is the same thing as 3/2. When I combine the 3/2 and the 1/2 together, that equals 4/2 or 2. And 2 plus 2 is 4, plus the 3/8 all adds up to 4 3/8, which is the same answer that we got on the last slide. And so that's how you can use an area model to show your students why you don't just multiply the whole numbers and the fractions together. You have to multiply the whole number by the whole number and the fraction by the whole number and the fraction as well. Because if you just multiplied the whole numbers together, you would get this part and this part, but you would be missing the green and yellow parts of the rectangle, which is a pretty significant part of the area of the rectangle. So this is one way that you can multiply mixed numbers. You can essentially make 2 copies of 1 3/4 and then make a half a copy of 1 3/4. And you kind of do it in 2 steps, like you make 2 copies of 1, 2 copies of 3/4, then you make a half a copy of 1 and a half a copy of 3/4. But there's also another way that you can multiply mixed numbers, and this one tends to be a little bit easier if you aren't drawing out the picture for the area model. So the way that this method works is to convert the mixed numbers into improper fractions. So if I wanted to change 1 3/4 into an improper fraction, I would say, well, the whole number 1 has 4/4 in it. And if I do 4/4 and 3/4 together, that's going to be 7/4. Then for 2 1/2, the number 2 has 4/2 in it. And 4/2 plus 1/2 would be 5/2. And once I have the improper fraction versions of these 2 mixed numbers, then I can just multiply the fractions together like regular fractions. And I can say 7 times 5 is 35. 4 times 2 is 8. And if I divide 35 by 8, I'll get 4 whole numbers because it takes 32/8 to make 4 wholes. And I'll have 3/8 left over. And notice that you get the same answer that we got with the area model or with the number line model. It's just a different way of thinking about it. So that's the last way that you can multiply mixed numbers. So you can either visualize it on a number line, you can do it with an area model, or you can convert the fractions into improper fractions and multiply them together that way. I would recommend teaching students with the area model and then teaching them the improper fraction method, because the area model really shows a visualization of why mixed number multiplication works the way that it does. And when you're multiplying mixed numbers together, it's helpful to use estimation skills to make sure that your answer is in a reasonable range. So one way you can do this is with range estimation. So remember, the way that you do a range estimation is you round the number down and then you round the number up, and you know that your answer will be between those 2 results. So what that would look like is you would say 4 times 9 equals 36 and 5 times 10 equals 50. So I know that my answer needs to be somewhere between 36 and 50, which is a pretty big range, but it gives me kind of an idea of where my answer should end up. Another way you could estimate it that's a little bit more precise is you could round the mixed numbers to the nearest half unit. So 4 3/8 is closest to 4 1/2, and 9 1/16 is closest to 9. And so if I make 9 copies of 4 1/2, well, 9 copies of 4 is 36. 9 copies of 1/2 is 9/2 or 4 1/2. And that would give me 36 plus 4 is 40. So I'd get 40 1/2. And that's a little bit more precise of an estimate than knowing that my answer should be between 36 and 50. But either one of these methods would give students a good ballpark range for where their answer should end up. So that's how you can use estimation to help you check your answer when you're multiplying mixed numbers. If you guys have any questions, let me know, and I hope you guys have a great day.